Okay, let's remember to hit start on the YouTube stream this time. Hope life is going well for you, Spetri. Okay, YouTube stream's up. Okay, so I was gonna start with let me just show the actual assignment. So we have to learn about the Rilbert operator, which I don't know what any of this is supposed to mean or do. But I've been blindly going through the math, and my answer is just slightly off, and I think I figured out why. At least part of why. Business like usual? Alright, fair enough. I think I made an error with my, with a Taylor series expansion that I did at one point. And I was gonna go to Desmos. Cinch pi x 2h sum n equals 0 to, we'll say 100. School, it's going like so I guess. It's like I really love the things that I'm learning, but it's the work is just relentless. Like the homework, it's like it's kind of stupid. Like it's not even all that good, but or it's not even all that like instructive. But what are you gonna do? Pi for 2h minus k pi. Ooh. I just realized Decimal's gonna yell at me for using imaginary numbers here. I can actually do this with sine. Can I? I can. How many hours do I have in homework? All of them. It's this is basically a full-time job. Like, I like for like an assignment for one class, like for this class in particular, is probably at least eight hours of work, and they assign that every week. For another class, it's probably 10 to 12 hours every 2 weeks. Well, it's 10 to 12 hours over 2 weeks, but they don't teach you the things you need to know to actually do the homework until closer to the due date. So you don't really have two weeks. Yeah, it's just it's really time consuming. Like I don't have a lot of time in my life now where I'm not like thinking about homework or math in some way. No, I'm a good bit older than most of the people in my cohort. Most ones who I've talked to are like 22 years old, right out of their bachelor's. It looks like a monster mouth with a scar on its eye. It's a good observation, hard locked. And that's not uncommon. Music's a little bit loud, isn't it? All the birds, yeah. Hey, Gold. Like, this homework assignment. Okay, so the thing that more people have heard of, we're learning about the Hilbert transform, but we never talked about any of this in class ever. So I don't really know what I'm doing about, like, with any of this. But then there's also, like, I tried Googling it. We're also doing something called the Rilbert operator, and nothing came up on Google when I searched that. So I think this is some professor's pet little project thing. I think it gets used in physics. Yeah, it's used with signals in some way. It has something to do with Fourier transforms, but like a different version. I'm not sure that it is. It could be. This is the 11th version of this homework because there's been so many typos and they keep putting out new versions. It's possible that's a typo. They do it twice though, at least. I don't know. Hey JC, those are babies. Are you like 22 also Spectre? Collar cone. Oh, VIP for 30 days. All hail collar cone. I do this kind of homework in my sleep. Oh yeah, hard luck. It's like some light reading. Didn't know you were taking alien languages. You know, just all I have to do is copy paste this, give it to Chat GPT, copy paste Chat GPT's answer, LaTeX it up, and then I'm done, right? Does this dude name something starting with R? I think I'm assuming it's not a typo because I think it's a spin on the Hilbert transform because they do make a point where from this Rilbert transform operator thing, you can take the limit as h goes to infinity and you get the Hilbert transform. So I think Rilbert is some pun on Hilbert or something. I don't know. It's gonna be my Halloween costume. I haven't dressed up for Halloween since college. um and even then, that was only 1 year, and before that I hadn't dressed up since I was a kid. So my costume is gonna be whatever I happen to be wearing that day. You can imagine being 22, Spectre. Oh yeah. Notice is over halfway to 22. Ooh. So more than 11? That's pretty old. That's all I do for work. 9 hours work is now AI done. Dang. JP can do. Oh, that's fair. Yeah. That's true. I am back in college. I was wondering if it was like Hilbert in real variables or something, but I think Hilbert's already in real variables, so it might be something else. Copilot greater than ChatGPT, Claude greater than all. The last thing I dressed up as, I don't know if I should even be saying this on stream, but the last thing I dressed up as, I think it was like 2015, back when it was still a joke. I dressed up as, because I have the same first name as him, I dressed up as Trump. There's a really funny picture of him playing tennis, and so I dressed up as like him in that picture. And then the next year became like a real thing. It's like, it's a little less funny now. Get 1,000 follower before Halloween. Wait, I have 1,400 followers. You just want to make me dress up on stream? So actually, physics And depression. I've seen him wearing a costume on stream. It's like a ridiculous giant like squid costume too. Oop, I misspelled it. Oh yeah, Harlock, I'm kind of sure to try out that Phasmophobia update sometime. I don't know if you'd be down for that, but oh, we're saying the same thing at the same time. You played Phasmo in a scary clown mask one year. Ooh, that's cool. My hotkey to mute my mic for whatever reason switches my tabs in my browser, so that's why I flashed the YouTube screen for a second. Did huge Phasmo booth at TwitchCon? Ooh, that's cool. What did they have there? Like, or I guess did you like visit it? Um, hey mouse. Oh yes. What was I? Okay, so this idea with Desmos isn't that good actually. It's not a book. It's a homework assignment. Trust me, you don't want this. And actually, I do have tea, which is like a throwback because when I first started streaming, I had tea pretty much every single stream. Yeah, principal value. Okay, the thing I was trying to troubleshoot is my Taylor series expansion for Cinch. The thing that I think I did wrong is that's well, okay, so the Taylor series for Cinch of X is frickin' n equals 0 to infinity x to the 2n plus 1 over 2n plus 1 factorial. But the thing is, I have Cinch of pi x over 2h, where h is a constant. And I'm just going to derive this from scratch. Because yeah, I don't know. Yeah, that's what I was doing at first, Catmaster, but I'm trying to expand Cinch around an imaginary point. So it wasn't, Desmos just isn't going to do it, except around 0. Um, well, yeah, so the thing that's, I think there's an error in my residue calculation, because when I think there needs to be a coefficient in front of here. And there needs to be pi over 2h cubed in front of this one. Because that would fix... So I'm getting an answer that's off by a factor of pi over 2h. And so I think I made an error in this expansion. And that's why I just want to do it from scratch. Oh yeah, I still need to figure out that schedule stuff, Cold. I might just like I've kind of been streaming on Tuesdays and Thursdays, so I might make that my schedule at least for the next like 2 months that this quarter lasts. Um, Tier series. Oh yeah, I'm still not used to Dr. Gold streaming this much too. It's great though. She was turning into animal lately. I believe it was the bear stream. Yeah, it's all about animals now. You get that previous expression you wrote. Yeah, like. So I'm trying to calculate the residue of e to the ik v is my variable over cent of v over 2h where h is a constant. And I want to do it around all of the singularities. And the singularities happen when the argument is equal to some multiple of pi I. In order to actually get the residue, I think I need... It's a simple pull. I could do the derivative thing, I think, but... Like, I think the residue that I've gotten here, it needs a 2h over pi in front of it. I think this should be my answer, but I haven't gotten that. And so that's why I'm worried about the coefficients. It's just a Google Calendar, everything I do on Google Calendar for my normal life. It's easier to move around than going to Twitch and trying to find where the dumb schedule thing is. Yeah. The Twitch schedule is weird. Hey, Saffron, it's going good. How about you? Yeah, the residue. Because yeah, this thing, it ends up having infinitely many residues that get closer and closer to the origin. Like we're gonna be using a contour. I'm only focusing this contour on the top here, and we're getting residues that are like on the imaginary axis and getting closer and closer. So we need to get the sum of all of these. And it becomes a really easy geometric series, so we know the infinite sum. But I'm still off by something. No, it's not geometric progression. I mean, that's involved in like one small step here, but this is a lot more than just that. Skirtle, doo-doo-bert. Hey, Sockno. Skirtle, if we are playing Repo today, I'm down to do it at any time. I'm just kind of doing this until we start or until I get tired. But if it's tomorrow instead, that's also fine. And actually, so it is a simple pull. I kind of want to just see what is the... There's the other way of getting the residue for simple pulls involving just doing the derivative of the bottom. And then plugging in this. So that would give me the pi over 2h that I always dreamed of. So I've definitely made a mistake with my expansion or something. Just waiting for Jake to wake up. I've been playing since the update. Oh, you sneaky snake. You've already been playing it? I thought we were all going to experience it for the first time together, but oh well. Yeah, that's what I was doing here, color clone, with the limit computation. I just got confused on expanding cinch as a series. I did it wrong. I did it wrong because I'm not just going to, like, because of this V thing. It's so fun to fight with kids in public lobbies, is it? Because I think I did it wrong. Um, you made one or two cry. If they're being little shits, then yeah, I guess that does sound fun. Hey, Adia. Gonna study? Alright. Good luck, mouse. Both fun and scary at the same time? Oh yeah, Halloween is coming. Stack bodies and break lobbies. What does behave mean? It means go crazy and riot. Oh god. Good luck, Adia. Disguised as a cone for Halloween? Nice. I'm also like I've run into this before, but like I'm kind of confused on like how to phrase this limit. Like I made the entire thing my variable because pi over 2h is just a constant, but that kind of feels wrong. Oh yes, suck now. I'm sorry that that stuff is happening. Oh nice, Saffron. Well, happy birthday. Um Actually, can I make Wolfram Alpha get the Taylor series for me? Pi x over 2h Taylor series. Yeah, suck. No, I'm really sorry about that. I almost like I don't even know what to say, but you know that stuff just isn't right, and I'm sorry that I would say it's making you feel that way, but that feels a little dismissive, like because it is like a real thing. Um, we need to compute the limit for plus or minus cosh x. Turning 18 next year. Oh wow. Yes, suck. I'm sorry. I wish I had some better or like more comforting words, but I was kind of like struggling there. Oops, sorry. For plus or minus cost checks, plus or minus sin checks. I made a typo. You only need to compute the limit. I'm not sure why that's true, color cone. If I see to compute the Taylor series of cosine at pi over 2. Sure, yeah. Saffron, if I do stream it, it'll normally be on Tuesdays and Thursdays. I don't have like a hard and fast schedule though. Depends what's happening in my life. Oh. Let's see if I can um I can try to figure them out for myself, but let's see if I can find those listed. Hey, Fembucks. Hope you're doing well. Yeah, I guess we'll do that. I do always forget. I don't have the frickin' book up. The solutions manual is here. Oh yeah. I always forget. I know cinch of IZ is some version of sine. Here we go. These are the ones I want. Oh my god, I have too many pages. Let's just insert another page. So we have this. And we have this. All right, it's talking now. Sounds good. Thank you for the work. So we want to go by multiples of pi. guess the first thing... Just translate that so that they come in the other order. And so the thing that we actually have is sinh pi v over 2h, which I believe is real. And we want to expand it around an imaginary number, n pi I. Three streak, hell yeah, thank you. So three, I mean, it's still more than zero, but yeah, it is like the least streak you can have. Anders, holy crap! I hope you've been good. How's life? So it's good to see you pop up. Sub and n pi I sinh into sine give you some nice periodicity in pi. Yeah, like sinh of an imaginary number is just sine. It's like yeah, of a purely imaginary number. It's just kind of annoying because sine has twos, like sine has a zero here, but also a zero there, and these aren't like, they aren't the same type of zeros. Like the tangents go in opposite directions. And I'm worried about some like sine flipping stuff. Like they're not all the same. So that, like, that's why I just kind of want to bash out the manual formula, because I'm really unsure of what's happening here. Like this is what I want to do right now, because I'm not gonna feel secure in anything else I do. I don't think. But no, I still I hate this coefficient. So I feel like it matters. If we were expanding it only around zero, I would know how to deal with it. I feel like when we're not expanding around zero, this coefficient is really messing with me. Um, well, kind of like the little sub problem that I'm trying to do immediately is uh I have e to the ikv, v is the variable, over sinh of pi v over 2h. So k is a constant, h is a constant. I'm trying to calculate the residues around 0 and in the upper half plane. And I did it slightly wrong. The answer that I got is I should have a 2h over pi in front of my answer. And I didn't get that, I think, because I made an error in Taylor expanding sinh. And it's just a really finicky thing when it's not just sinh of v, it's sinh of pi v over 2h. And it's about an arbitrary, like, n pi I point. And so I'm struggling with all those, like, moving pieces. And also, give me 1 second. I just finished my tea and I want to put my mug away. You forgot everything about residues? No worries. um, and so if you know that it's a simple pole, there's a really convenient formula where if you have a function that's like p of z over q of z, the residue is just p of z naught over q prime of z naught. And so if I use this formula, I do get that 2h over pi thing that I need. But I still want to try and, like, I want to justify that it is a simple pole, so I still kind of want that Taylor's series expansion. But I'm not doing that right. And it's really annoying. Lux, that integral looks insane. I'd rather not do that. You can't tell me what to do. Not H. You know, Wolfram Alpha, you're kind of annoying. Did I finish my neuron work? I think I have one last homework. Yeah, I do. I have one last homework on neurons. Come on. We're using, like, probability to simulate when a neuron builds up enough charge to have a spike. This is like our last bit on neurons that we're doing. And then we're moving on to like cancer modeling. So the probability of my understanding this. It's kind of out there. This is gonna be stuff that you probably haven't seen before. With like matrices. C plus 1 to the fifth plus z to the fifth equals 0. I assume you could just let z be re to the I theta and work your way through that. Oh, let's do theta plus 2 n pi. When does x goes to infinity of 1 over x? Undefined? Question mark? Uh... Oh, wait. Okay. The multivaluedness does not... Hmm. It doesn't come from this. It comes from -1. That's the trick. Because now when I take the fifth root of each side is when things actually... Like, this is where we get the multivaluedness. I was wondering why... I thought I was going to get it from here, and I wasn't, so I got confused, but... Just R. Um... This is getting kind of annoying. Twelve over 5 n pi? Question mark? Was in the cinch. Pi v over 2h. Yeah, I did assume that. Maybe that was dangerous to assume. I did just kind of get stuck with his current step, though, so... I don't know how we would... Like, the only thing I can think to do is to subtract this over. It's equal to the 1 subtracted over here and put into polar form. So, like, the radius of z is 1. I don't know how you figure out the argument, though. Also, just have the same real part. My instincts on the integral from earlier were right. It's a mean one. Oh, the one that in the YouTube chat? Yeah. When someone in the YouTube chat just they don't say hi, they have no intro at all. They just put an integral in chat with nothing else. I never do it. Because they're never putting integrals, like they're always putting competition integrals or challenge integrals. The number of times people have tried to get me to integrate square root of tangent is ridiculous. Haven't been lurking about trying to integrate x squared e to negative x log x. No, sir. It's 3 minus 2 times Euler's gamma constant. Oh, God. I like the Euler macaroni constant. I don't know how to do that, Anders. I kind of want to go back to my homework. I don't know how you prove that those have the same real part. Or I assume this is just like a for fun quote question. If there's something that you really want to like talk about with this, then sure. But I don't know how you would prove they have the same real part. Why does the financial aid office still need my parent information? I am old. Hello? Really? That is weird. It's a fun equation. Looks so innocent. It does. Like, even if you're over 18, like, you can still get, like, the parent plus loans depending on their income. Maybe that's why? But, like, you shouldn't need it. Like, I don't know. $27 as far as I know. They still want the parent information. It's annoying. Okay, I think for the cinch situation, I assume this work isn't helpful, so I'm just going to delete it. Because this thing has way too many pages already. For this whole cinch situation, what if I compute just cinch of x about n pi I? And then at the end, I do a little switcheroo with x equals pi v over 2h. Will that get me in hot water? Okay, so f0 Oh, n is a poor choice of constant. There's too many letters in this problem. I don't think I've used m. My infinity looks like a 6. It does. Thank you, Jed. That integral isn't so mean after all. Oh, it's like the gamma function. Okay, yeah. That's a good spot. Okay, so sinh of any multiple of pi I is 0. Cosh. Ooh, that's either 1 or -1. Oh, is it that song? No, this I think it's a different song. This one is called Placeholder for the Night. Okay, so if m is 1, cosine of pi is -1. So -1 to the m? Yeah. Esco. Yeah, it's some crazy math. I'm not gonna lie. A few months ago, I started on a master's in applied math, and they're making us do things that they never even taught in class for homework, and it's kind of getting crazier and crazier. It's going good. It's kind of been busy with all the homework and stuff, but it's good. How about you? Yeah, so like this here, it's a function called cinch, and it's a really weird one that most people don't learn about unless you go like really deep into math. That's in like my math department. um I don't this isn't wait, no. I forgot something. I took a derivative. No, I can't. Okay, no. Fuck this. We're expanding this, whether it likes it or not. Because the thing that I want to, when I take a derivative of this, I'm going to get the pi over 2h. And here I'm going to get pi cubed over 2h cubed. Setting exponential functions. Oh, nice. I didn't know that you were studying. Yeah, it like um I don't think any type of math is like easy. When I first learned that stuff, it wasn't easy for me. Up to a silly computation mistake. I don't know if he like normally does like if you ever have a question for me, let me know. I don't know if he necessarily does like math help, but there's actually a Spanish language like math streamer on Twitch. He's normally talking about like pretty like high level math, but in case you ever like curious to like, I mean, he might be able to explain to you in Spanish like certain things in math if you were ever like curious. You're a mechanic guy, you never like math. Oh, that's fair. And of course, you're welcome to ask me too. I just know that you're more comfortable in Spanish. Um, that's fair, yeah. Um, I still think this is a little bit weird, but actually, if I go back to Desmos, oh wait, no, but Desmos, no, like learn, yeah, like learn more words. I don't know if my Desmos thing is really all that helpful. I feel like I'm not setting something up right with it. For Daddy Bezos approving my PDF. Okay. Like I I think I'm about to just like on my homework I just won't explain it. I'm just gonna have a pi over 2h in front here and a pi over 2h cubed in front of here, because I think that is what's supposed to be happening here, and it's just being annoying. You do have it in your computation? Okay. I think I'm also off by a negative sign, which I haven't found yet. I don't know if the mistake comes from this part, though. The negative sign might be somewhere else. Yeah, it's this is the red one is a sine curve, and in Spanish I know it's sen. I don't know what the full word is in Spanish. Uh, the green curve is it's basically an exponential curve. A quadratic curve would be like 2x squared plus x plus 1. This black one will be a quadratic. No worries. You know what might be in your expansion? Mixed terms from the product of two expansions. Would it? They have different like variables though. One is IKV. The other one is pi v over 2h. So I kind of assume there wouldn't be any interaction there. Yeah, that's the goal, to make math look simple. Or at least like make it, hopefully actually make it simple for people. Dora, it's messed up. I don't even know what I'm doing. The homework that they're assigning has nothing to do with what we're doing in class. So I don't really know what I'm doing. It has like very little. Hey Jaden, I'm doing good. I am in math class right now doing homework. We're doing 3D coordinate systems. Oh god. Well, good luck, Jaden. Um the notes are 0 to 10? Like our grades? They're usually like A, B, C, D, E, F. Although the school I'm at uses numbers, I think like 0 to 4 or something weird. Wait, did I say E? There's no E. A, B, C, D, F. Zero to 7. Oh, interesting. Engineering uni said, "Med, they won't need this." Yeah, this is the type of stuff that you would skip over and just learn the end result for engineering. To a silly mistake, this should be it. Okay. So you just let my constant be alpha, that's fine. Center at I n pi over alpha. Yep. Oh yeah, you know, okay, if I do this. Oh my god, okay. Uh okay, yeah, yeah. Sounds good, Esco. Thank you so much for saying hi. I'll see you around. Replace the pies and e's with threes and get some nice cancellations. That's perfect. You know, I think I could have just taken my work and factored out the constant. I should put the -1 in there because that actually that might solve the mystery of the missing negative sign. Yeah, okay, so actually like our work is gonna be the exact same, but I just need to factor out the pi over 2h. So this is kind of annoying. Should we just delete this and rewrite it? I think that's what we're doing. Okay, so we do need, it's gonna be, okay. It's gonna be -1 to the n pi over 2h v minus um 2h n pi I over pi? Am I dumb? Wait. No. No, that's good. Plus minus 1 to the 3n, which doesn't change anything. Right. Pi over 2h cubed v minus 2h n pi I over pi cubed plus dot dot dot. Okay, yeah. And so the point is, like, all of this stuff over here is going to disappear. We do need to rescue the minus 1 to the n, because that's actually important. I was going to do plus dot 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 because I don't feel like writing this entire thing out again. Okay. Minus 1 to the n. Okay. So now we need to actually this becomes a geometric series in n because we need to sum up all the residues in order to calculate the integral. And I have a feeling that I made a mistake somewhere in here too. I think I've made a mistake in dealing. So what we just did is we fixed all of the singularities that are on the imaginary axis, and as n gets larger, it gets closer to the origin. But there's a singularity right at 0 that the little circular part is closing in on, and I think I didn't deal with that properly. So that's why this geometric series starts at n equals 1, because I wanted to exclude 0, because I think it only contributes half a residue, and that residue is 1. Wait, it wouldn't be 1 now. It would be 2h over pi, but that's still... Ooh, is that important? I don't think it's important. Just get rid of this. Get rid of all this. Pi times I looks like pi written out. Yeah, it does. It's really annoying. It's like, if I go to type it into like Wolfram Alpha or something, you have to put like a space in there. Like, you can't just do pi I, because then it gets weird. And this 2h is, it's good. I want it to be there, because we had an over 2h earlier on in the problem that we wanted to cancel. iPie, the new Apple product. Yeah. So this integral here, it's going to be equal to something. The sum of the residues inside of the contour, which is this. But the little circly bit, what is that contributing? It's just, I'm trying to justify making this into a minus sign. Because we need to remove the contribution. No. I don't know. But let's just see if the math works out with the minus sign first. That way we'll have a better idea if this actually gets us the right answer. I, let's take this a little bit slower. Oh, look, hi. Hi, my name is... Message won't send, dang it. My parents keep saying that doing a TU is really tough, and by far most people can't do it, but I'm wondering if it's kind of below my level. I'm not saying my ego is too high, but I'm saying that you only need 4 hours of math a week to get into that technical university for applied maths. So I have 6 hours of math a week. I'm wondering if the TU is too low level for me. That's hard to judge. I don't know how hard a TU is. There's only 2 unis that give math on a level that are applicable to me. It's actually too low level. are you able to look at what they're actually going to teach you? Like, are you able to find out what the classes are and even like get a syllabus or something that describes like what it's going to be like? Because I don't have any experience with like TUs or anything, so I don't know if they are hard or not, I guess. I'm subtracting out 1 here because this geometric series starts from 1 and not 0. Part 2, there's only... Oh, yeah, okay, I read that. I know that if you get 6 hours a week math in high school, you have stuff in the first year that is repeated. Yeah, I was wondering what this song is. It is a little bit weird. This playlist hasn't been my favorite so far. I might switch it up. Okay, the stuff that is repeated from what you've already seen for the difference between 4 and 6 hours. For example, complex numbers, epsilon delta. Human students with 6 hours haven't seen epsilon delta because I go to school in Belgium. Math is slightly harder there rather than in the Netherlands. Yippee, let's go to the carnival music. So this is like, it's hard to say exactly like yes or no, but it definitely doesn't hurt to apply. And if you get accepted, like it might be a challenge, but you could also just challenge yourself and see if you're up to it. Worst thing that happens is you figure out you can't do it, which there's no shame in. Do my parents look at in the Netherlands while I look at KU? Oh, are those the names of the schools? That's kind of interesting. It's like here at a technical school means like it's like a school you go to learn to be like a welder or like a plumber or something, like a very like manual job. But it sounds like a technical school over there is different. Do you have an experience day in February? Oh yeah. So if you can actually meet people from there, that's a really good opportunity to like learn more about it. Oh, okay. So it is more like engineering-ish. Okay. I would assume that you would go for pure math, to be honest, with the types of things that you normally like want to talk about. These coefficients aren't working out. I always forget this with geometric series. If it starts from 0, the formula is a over 1 minus r. If it starts from 1, it's like weirder. Like what I was trying to do is just use this formula but subtract off the n equals 0 term. I'm worried that I didn't do that right. Really? The start point does not matter. But isn't the first term here a times r? Because n equals 1? That's okay. I feel like it's just gonna end up being the same thing. But let's see if this does make a difference somehow. I think what I did is also right, but it's I don't know. Do not know. I need to get in a hyperbolic tangent at the end of this. So if I don't get that, something is wrong. Something is wrong. Okay, so I want this to be addition, maybe. I'm not gonna bother trying to justify which one it should be yet, but let's do whatever gets us the right answer. And worry about why afterwards, I guess. And so this is actually, I think this is the exact right answer now. Not 2, just HK. That's hyperbolic tangent. And this is the exact thing that we need now. Okay. I still don't know why we're adding that. I guess I can just say it's the modified residue theorem. Same mistake never matter in practice anyway. Rocket heading towards ground. So we can back up and this, so in part A we ended up on this step here, and the entire time we've been dealing with this integral inside the parentheses, but now we've evaluated it finally and we're ready to back out and say this equals e to the IKU over 2h times the thing that we just found. For positive k. There's another half to this for negative k, which I have not done anything with. Is that our hat? Oh, of course it's our hat. So you just put hats on everything. I hyperbolic tangent e to the IKU, which matches that bad boy. 4H transforms had a big birthday. Okay, well, we've done half this question. Basically. I really don't want to do the other half right now. I think it's going to end up being the same thing. The only thing that should be different is we should get a double net negative somewhere that's going to cancel out and give us the exact same thing for all k. Oh, I didn't figure this part out. Actually, no, we're not done with, we're not even done with half of part 1. I forgot there's a part F. F's in chat for part F. So they're giving us this principal value integral to get now. And the thing that they want us to notice is that it looks a lot like this integral that we just did here, but instead of e to the IKV, we have sine, so we can just take the imaginary part of the thing that we just did. But the thing that I don't understand is that this thing has h's in it. And the problem they give us has no h's, and so I don't know what that really means. I was thinking that must mean, I guess that means, does h equal whatever it has to cancel out the coefficients? So I guess pi over 2. I did get a numerical answer from Wolfram. It was like 2.88, I think. Also, what does... I don't know what to do with the e to the IKU. It's centered at 0. I think u is the center. So u equals 0. Okay. But if... K is 1. So what is hyperbolic tangent pi over 2? Not what I want. Hey, IVK. Yeah, it's crazy. I don't even know what it is. Oops. So it's sine over sinh. So 2.88 is what I expect. Hyperbolic tangent of pi over 2 is not that. It's called hyperbolic sine or sinh. If sine has regular sine has to do with the unit circle and area inside the unit circle. Hyperbolic sinh deals with a unit hyperbola instead of a unit circle, and area underneath that is the quick answer. I don't really know in depth much more than that. I missed a factor of pi over 2. Did I? The proof I don't know. Oh, you've seen it? Okay, okay. Go up to my exponential form. Like here or like at the very beginning? Even higher? Okay. So this is the original problem here. Wait, nope. This is the original problem here. So I was thinking that u is 0. So each like a 0 is just 1. That might not be true. Something changed? I don't know. I don't think I changed anything. Sounds good. Sleep well, IVK. I want to get this all on one screen. Bring in a screenshot. It's a little bit confusing because we're using u as a variable in the integral. But down here, u prime is the variable. Oh, oh! Well, the h I'm making it cancel though, so it just becomes 1. Wait, actually, but maybe I'm supposed to use this 2hi. If I take pi and I multiply it, two eight eight, 288132, 288132. Oh my god, wait. Okay. So actually, JC, like, that wasn't the exact right thing, but it was, this 2h in front. So, okay. Thank you, because that got me on the right track. We didn't want, what am I trying to say? Oh, I don't have solutions, IVK. I just have, I can use Wolfram Alpha and stuff, but they don't give us the answer key until after you turn in the homework, so I'm stuck. Okay, so I was trying to use this, but this isn't exactly the result of the integral. Well, it is. Wait. They're asking us to compute this integral, which is slightly different from the transform. Because the transform has the 1 over 2h to cancel out the 2h that I got as a result of the integral up here. So 1 over 2h, that's vector pi that you're missing. Well, if h is pi over 2, then... Oh, wait. Oh, maybe you're also right. Yeah, I guess maybe we're both right. Yeah, I see what you mean. What you mean. I don't know. Okay. Well, but that'll be 1 over pi though. If h is pi over 2. Solving for the integral. Oh, fair. Multiply to the other side. Okay. Okay, yeah. That makes sense, yeah. So then you and I are doing the same thing. Okay. The world makes sense again. Great catch, JC. So what's happening, so it's to help out future me. We're taking this, let h equal pi over 2, u equals 0, k equal 1. Okay. Goddamn. Okay, I think that works. We're gonna have to swing back around and do negative k at some point, but That'll be an off-stream thing. So that was Rilbert that we just met. We also need to talk to Hilbert. His equally as annoying cousin. I think I was doing this one off stream. Maths worked and didn't break, for once. And this question is just ridiculous. Thankfully, the Hilbert transform is something that is like well known and has a lot of material about it. The Rilbert transform is not. The Hilbert transform is very similar to the one we were just looking at, though. Just and there's no sign in the denominator, and there's no h. So what's happening here? So they want us to basically get the Hilbert transform of e to the IKU. So we set up a really similar integral. We do the same substitution to center it at 0. I think so, JC. I've never learned anything about this before, so I don't really know, but I think it's like that. And also, imagine never having learned anything about this before and seeing this on your homework. But I think it's an eigenfunction like thing, or it's some especially like nice thing that behaves well with the transform. It's applied complex analysis. We've been doing residue calculus and stuff like that. We have not been doing anything with transforms or pseudo differential operators. I don't know what that even means. I think I did this right. I'm pretty sure I looked it up and I saw this pi I sine of k function thing on the Wikipedia page. So I think I did part A right. How do you apply complex analysis? Didn't even know you could do that. You can, because we're going to be doing things like Laplace and Fourier transforms, which you don't need complex analysis to apply them, but they are a lot more elegant if you do use it. I think that's an accurate statement. And aside from those transforms, complex variables, if a complex function is analytic, that can have a physical interpretation with like fluid flows and like any type of like vector field, really. Okay, so I took the limit as h goes to infinity, and we obtained the Rilbert transform. The thing that I think is ridiculous to ask on this homework is, on what sort of domain might the Hilbert transform relate the real and imaginary parts of a complex analytic mapping? I don't fucking know. To be fair, they do say it's judged only on completion, but I don't even have the tools to even begin to answer that question. I think I'm going to show up to the office hours tomorrow and be like, what the hell? In a nice way, but like... I I think what they're getting at is like what's called a harmonic conjugate, where if you know if you know a function is analytic and you know the real part of that function, you can figure out what the imaginary part must be because of the Cauchy-Riemann equations. Space Lobster 2, thanks for the follow. And so there's a relationship between the real and imaginary parts of a complex function. And under this Hilbert transform, they might have some special relationship. So for Cauchy-Riemann's thing, yeah. So this is one where like I need to do a lot more Googling if I'm going to answer it on my own. And I might do that on stream. I don't know if I... You know, let's do at least a quick little Google. Hilbert transform. Space Lobster, welcome in. I learned super fast and math is my best subject. How quickly do you think I can teach myself Calculus 1? This is a legit question. I finished intermediate collegiate level Algebra 2 in 2 nights. I was only 0.3 points away from a perfect score. Jeez. You're apparently some type of superhero. I'll say in my personal experience, calculus was a completely different animal from any math class I had taken previously. It took me a good few weeks of really thinking about it hard before it kind of clicked for me. But if you can learn math that quick, like, I don't know, like 2 weeks or something. It's kind of hard to answer because it's a personal thing, but it sounds like you can learn it pretty quick. I'd say it's a lot longer than collegiate level algebra, but for you, maybe it's still not that long. Yeah, this has it has something to do with signal processing. It imparts a phase shift, and that is something. I'm really pulling at the words that I'm taking out of my ass right now. And they don't sound very convincing either. Thank you so much for the sub, Space Lobster. Wow, I appreciate that. Superpowers ADHD, my ability to type books on things I find enjoyable. Fair enough. I will say if you run into issues and you have questions, I mean, feel free to let me know. But also, if I'm not around, there's a whole there's a math niche here on Twitch that I like to let new people know about. So you ever know that top list? Oh wait, I put FizzBuzz under the help streams. I don't know, but wait, I think FizzBuzz got moved. Sorry, FizzBuzz. You should be under the study streams because I believe you don't typically take like questions the same way that a lot of us do. But yeah, everyone in the top part of the list does like math help in some way. Oh, okay, fair. Sorry, I try to be careful how I describe other people's streams because I want to like do it justice. Uh, and also respect people who like want to talk about math but don't necessarily do like homework help. For an analytic function in the upper half plane. Oh yeah, I probably took it from this Wikipedia page, to be honest. uh Kirksological? Probably saying that wrong. Thank you for the follow and hello, welcome in. It secretly helps stream, yes, but the onus on the viewer to nerd snipe me. They have to ask an interesting enough question. That's fair. Engel's able to contribute to research on quantum computing and quantum resistant cryptography. Oh, that sounds amazing. Good luck with that. I don't know of like anyone in particular who I could like point you towards who knows about that, but it sounds awesome. Um, you know, okay, so this actually this might make sense. Let me do I have problem homework 1? Okay, wait. Let me Okay. Lower half plane never gets any attention. Yeah. Hey, Dessen. My end goal? Like with my degree? I don't know. I don't really have one. I've always wanted a higher level degree. Well, not always. I was specifically inspired by a professor of mine that I had in undergrad. But I don't know if that's the type of end goal that you're talking about. Okay, so this is from a previous homework. This is where we were first kind of talking about Laplace's equation. And the Hilbert-Rilbert stuff is an evolution of this. This has periodic boundary conditions. And where was the H? This is where we first learned about H. H forms the boundary. One of our boundaries? Probably, maybe? Yeah, it is, Dessen. There's a useful theorem from lattice theory used in lattice-based cryptography called Lenstra-Lovat's lattice basis reduction. Oh my god, that's a lot of L's. And a lot of Lenstras. Yeah, Kirk. So, I guess I'll just call you Kirk unless you correct me. So for background, I am a master's student studying applied math. And I I sometimes feel bad like showing this stuff on stream because it's probably very scary to people who haven't spent years and years studying math specifically and trying to go deep into it. Because I would love for the stream to appeal to people who don't like math and get people who don't otherwise like math to at least have some interest in it. But yeah, please know, like, I also take like math questions and I'm happy to talk about like, you know, how to add two fractions or something that's like, you know, just kind of early on in the math journey too. That it just tends to go towards higher level math conversations, I guess. But I don't want the stream to only be that. Lenstra related. Oh, fair. Scientists here, H is Planck's constant. Hopes this helps. It does, yeah. We're solving Laplace's equation over a domain that has a Planck's length of width. Can you brush up on discrete math and a few other fun stuff? Nice, nice. Discrete math is not my favorite, but I know that Ian Stuckey specifically, that's like their thing. Fortunately, you do like math. Oh, hell yeah. You don't have to if you don't want, but feel free to like share your background, like where you at right now and what your goals are. Your chat is the top 1% of math lovers in all of Twitch. uh, I was just thinking about that yesterday, where like math streams are kind of funny, where in most other educational streams on Twitch, the streamer is the expert and they're educating people who are maybe interested in their field but don't know that much about it. Like Shane McInnes is like, you know, the expert on like history and sociology, and people in chat are like asking him questions and learning from him, or like science with biology. But at least for math, that's usually reverse. Like almost everyone here in chat probably knows more math than I do. And I'm the one who's learning from you all. As I guess I mentioned science. Let's also get a shout out for science. Is it science streams? I got it right. It's easier to look more. Yeah, that's fair, because you just stay quiet if you don't know. But like even then, like JC just helped me with a problem on my homework, and like if people like you, Destin, were like, you know about a completely like different type of math than I do, or like there's people with like full on like masters and PhDs in here too. No. I think I saw on your Twitter you posted some pictures. I don't remember if you had. I don't remember seeing one with like science. That is also the nature of math. That's fair. Yeah, if you want to like drop a link, feel free to. When I first studied discrete math, I thought it was supposed to be math done in private or very quietly. That's fair. There's a part of math called linear algebra, and when I first took that, I thought it would be about lines and y equals mx plus b, and in a way, it's kind of like that, but it's really not. I was in for a very rude awakening when I saw what linear algebra is actually about. A math teacher in my school, not even the one who was teaching me at the time, found me when I was in 9th grade, and he was like, "You're like, wow, way above everyone else. Want to go into 13th graders university preparation class?" I said, "Yes, of course." And now I know calculus 1 and 2. Hell yeah, Kirk. That's awesome. Do you think you're going to try and study math at like university too? Hey Rex, thank you. Linear algebra for the win. Oh, you like linear algebra? Nice. It's a really awesome subject. Real analysis is not real, bro. Real analysis is fake. I'm an avid real analysis hater. I don't know what's fake about it. Seems real to me, at least. Do you think math education majors should not exist and instead take math majors to become math teachers? Ooh. uh No, I'm okay with math education being its own like subfield, because the best mathematicians are usually the worst teachers. Teaching is a separate but related skill to being good at math. Because if you want to teach something well, you do need to understand it at a certain like deep enough level. But it's a completely different skill to take your understanding of something and communicate it to other people. And so I think that's a good enough rationale for it to be its own like major. I'm in a chemical technician school, so I could go forward as a chemical engineer. Oh, that's awesome too. chemistry is one of those things where like I really want to like it, but when I took an actual class, I just could not really get into it. Hey, Puika. Realness is just propaganda. It's actually fake. It's the government wanting you to think it's real. It's a good point, JC. I finished my bachelor's in computer science, and I will jump straight into my master's for comp sci. Nice. The fast track program, so I should be done next year with my master's. Been flying through a lot of my classes, so I should finish sooner than anticipated. So I'm gonna go for your PhD. Good luck. That's awesome. I think it's okay to show on stream since you put it in chat. Oh, hell yeah. Oh, there you are. Nice. That's awesome. I'm sure that was a really like good time. Couldn't get Dr. Gold to come. It was at 7 a.m. Oh yeah, that'll be a hard sell for me too. That's kind of early. I mean, I would absolutely love to go to TwitchCon and to do the beach cleanup thing too. It would be kind of terrible to wake up that early, but maybe I would just get it done. I promise I'm working on the homework too, but chat is actually like moving quick, so I'm trying to keep up and not fall behind. Okay, so I did Space Lobster's comment with computer science. That's awesome that you're going super deep into computer science. That was my minor. And we might actually do some Python programming on stream here at some point if I get bored of complex analysis. Another problem is that schools like to put 15 plus people in a class. That doesn't help. Big class sizes are usually detrimental. If you can't explain your work to a 5-year-old, then you don't understand it. Ooh, I mean, I don't necessarily know about a 5-year-old. If you can't explain it at least to a peer, I would say. A 5-year-old, it'd be pretty hard to... Well, I wouldn't say I understand this, but... I don't know. I think there's something that are a little too deep. My chem teacher was so good, I finished the whole course with 94% at the end of the term because of how good a professor he was. Oh, nice. A good professor makes all the difference. Here's like kind of interesting at the start, then you get dumped to a trillion different definitions. Yes. Then it gets interesting again. Then you get to organic chemistry and want to commit crimes. Thankfully, I never did organic chemistry, but yeah, I got a little bit done with all the stuff I had to memorize in chemistry. In 5 years, chat will have 20 plus PhDs. The chem guy, if you want to talk about chemistry. Oh, nice. The girl in the middle is so fashionable. Oh, who was that? Oh, with the pants? Those are some nice pants. The person with the paws? Oh, I keep closing out too soon. Yeah, the paws are awesome. I wonder if they haven't done like a face reveal. That's why they're blocking their face. Of course, you would enjoy the pause. Python scares me. I can learn actual languages easily, but Python, yeah, I'm not honestly. I don't like a lot about Python. I hate not controlling my data types. I hate that things are done with tabs instead of curly braces. There's probably more to it than that too, but that's just coming to mind immediately. But that's just kind of like Python is just the expectation, unfortunately. It does have a lot of really nice libraries with NumPy and SciPy, but yeah. Yogurt Girl, she does science communication adjacent stuff. Oh, cool. Five-year-old Terry Tell will be teaching me. Do we know these people? Oh, these are streamers. This is from the TwitchCon Beach cleanup. So like that's FizzBuzz right there. That's science. That's paleontologizing. That looks like Casey Snow art. That I think that's Nerduino. But these are all like streamers. And TwitchCon just happened like 2 weeks ago, I think. 1 week ago, something. And a lot of the education streamers did like a beach cleanup. Needs to learn Java at some point. Oh, that's one of the earlier languages that I learned. You don't see Slim? No, none of us were there. I would love to have been there. I had a little phase where I was like gung ho on going to TwitchCon this year. Actually, wait, I was DMing you about it, FizzBuzz. That's right. But with how stressful grad school has been, I don't know if it would have been a good idea for me this year. You need to on Java to make it easier. I don't know, it just feels like it's the first real language that I learned well. So to me, that's just like, it feels very natural to me because that's the terms that I learned programming in. If you learned like higher level languages first, it'd be a pretty difficult switch, I think. I'm not sure though. I'm sorry. That's kind of hard to answer. Because to me, it just feels like the basic, or like one of the basic programming languages that the other ones, like, you describe other languages in terms of Java, but you wouldn't describe Java in terms of other languages, I feel like. Like, that's how it works in my brain. It's nearly the same thing as C++. Like, in terms of, like, syntax. Next year, there'll be a robot instead of them all? Maybe. These are the cool streamers. They are all cool, and they all are streamers, so you could say that. In the chemical engineering course, I would need PD apparently at most for heat equations and such. We'd say it has a steep learning curve. Yeah, PDs are not easy. For chemical engineering people. Sorry. I imagine they're gonna let you just plug PDEs into a numerical solver and not worry too much about it. The theory of PDEs is very gnarly. That's what I'm starting to get into. I imagine that they're going to abbreviate a lot of that for you though. I'm learning German and Japanese in my free time. Does that count as higher level language? Maybe, yeah. I know some Python and Julia. Bros jumping right into PDEs, eh? Yeah, I've lost track of what I was doing. I've been yapping to chat for a while now. Which one of these tabs were... Okay, yeah. I'm trying to do a problem on the Hilbert transform. I think I've done A. I've done... Okay, so actually, let me preface this. We have not talked about any type of transform in class for applied complex analysis. This notation is completely new to me. Hilbert transform is completely new to me. We have not talked about it in class. And we're being asked questions like, on what sort of domain might the Hilbert transform relate the real and imaginary parts of a complex analytic mapping? And we've been applying this transform to Laplace's equation from our previous homework, which is what I was looking at here. And actually, I think I figured out the answer now. I lost track of what I was saying. But yeah, that's where the PDs came in from. So toughest course you took in grad, asymptotic analysis and nonlinear waves. Oh geez. next quarter, because we're about to do registration for next quarter, we're gonna be doing asymptotic evaluation of integrals, and I don't know if that counts as asymptotic analysis. I don't know why Don's not taking the 3 main courses. What are the 3 main courses? That would certainly be nice, since I tried my hand at a few ODs even. I haven't really grasped it yet. Yeah, if you ever wanted to talk about it, or like give me an example, just like let me know. But yeah, I imagine for non-math people, they're gonna let you, they're not gonna beat you over the head with theory. And if you just need like a surface level understanding, the YouTube channel 3 Blue 1 Brown is fantastic for this. 3 Blue 1 Brown. He has a whole series on differential equations that is quite good. Ah. So like if you just want a little like primer, I'd start like I'll watch these like first 3 videos even. Oh, good, yeah. Okay, heat equation contradicts physics actually implies infinite speed of propagation? Really? But time is one of the variables that you're solving for. Like, you can describe how it changes over time. It's not just instantly. There is like a steady state version of the heat equation, but I don't know if that's what you mean. An operator is typically written using math cal font. Okay. That's not evaluation of integrals. Yeah, I don't really know what that involves, but I'm sure it won't be easy. Next semester, I'll take linear algebraic groups, algebra 2, and probably experimental math. Ooh, experimental math. Why was the equal sign so humble? Because I realized it wasn't less than or greater than anyone. It's not a bad. Okay, so H determines one of our boundaries is how I'm interpreting this boundary condition here. And in the Hilbert transform, we're letting H go to infinity. And so I think the Hilbert transform is gonna, that's why the Hilbert transform is going to work on the upper half plane, because our boundary is going to infinity. Maybe it's only a quarter of a plane. No, I don't think that would matter, because you could always shift it, right? And what sort of boundary conditions would I expect the real part of such a mapping to satisfy? Decaying at infinity is my guess. It would probably have to with the definition of the transform. Yeah. Okay, let's write that down. Delete that. From problem 5 on homework 1, H determines wait, is it the height or the width of the boundary? For any U Oh, I guess it's the height. Okay. What? Oh, I'm clicked into OBS. The height of the boundary, y value. So if we let h go to infinity, then the Hilbert transform might relate yada yada on the upper half plane. I want to rant about asymptotics, posting it in Discord, and you can read or ignore it at your leisure. Okay, sounds good. Or if I can like catch your stream at the right time, could always listen to you do it too. Am I able to when I only sleep for 4 hours? Very slowly with great difficulty, I would say. No, don't I turn my own boundaries things. As is your right as a human. In British physics, they use like a modified version to accord propagation to the speed of light at most, I think. Oh, interesting. I've never heard of that. What's a residue calculus? I'll talk about that in a second. So it was related to what I was doing yesterday with integrals in the complex plane. Oh yeah, so you said you know calculus 1 and 2. So I'll try and ooh, I guess we should, for the boundary conditions, we say we should figure out an x direction or y direction or both. Okay, so how do we talk about this? Sorry, there's a bit of machinery that goes into explaining this, and I'm trying to figure out how to like distill that to someone who has maybe just learned what like how to integrate and how like single variable integrals work. I guess the first thing that we should talk about is residue calculus has to do with complex variables. So in the same way that we could do the integral of x squared dx from 1 to 2, we can almost do the integral from 1 to 2 of z squared dz, where z is a complex number. The reason why we can't quite do that is because complex numbers are two-dimensional. Like they have a real part and an imaginary part. And so the real number 1 is like, let's say it's right there, and the real number 2 is right here. And so while the natural thing, and like the question that comes up with complex numbers is how do you get from one endpoint to the other? You could go in a straight line, but there's nothing necessarily special about that. I could also choose to go in some weird curvy path like this. And like, how do you know which path you want? Whereas with a single real variable, that's kind of always determined for you, because you just have one input value x on this axis. Here we have two input values, a real and an imaginary, that get mapped to another real and imaginary number. So you kind of go from a two-dimensional situation here to a four-dimensional situation when you involve complex numbers. And so that's why I'm struggling to come up with a good explanation here, because this is a lot to get used to already. The thing that I guess I would stress is that with a single real variable, the path is always like easy to find. You go from 1 to 2 along the x-axis, there's nowhere else to go. And then you just get the height of the function and, you know, area under the curve and all that good stuff. Why is the derivative always so stressed? Because I had too many functions to take care of. Wait. I'm not sure if I get that one. How does one interpret integrating complex function? Does it have any relation with areas under the curve? Sort of. Yeah, it stops having a really clean geometric meaning, I think. I don't know of one. Like, this area under the curve thing is a really nice geometric meaning, and I think there is some type of area slash volume or something interpretation for an integral in the complex plane. I don't quite know, though, because things get four-dimensional, and who the hell knows how to visualize things in four dimensions. uh it is ultimately like built on the same exact thing, though, so that there should be some type of area interpretation somewhere. I'm just not sure what it is. So, and like with a real integral, like the theory is you can split this up into like very, very thin sub intervals and get the area of each of those little slices. The same idea applies with these contours, where you slice them up into very, very thin little pieces, and you figure out how the output looks over here, like what the actual value is at in each of those slices. Yeah, I guess color code makes a good point where if you have f of z equals z squared, you can always write complex functions as the sum of a real part plus an imaginary part. So if I let z equals x plus iy, I can make this a two-dimensional, like, they're both two-dimensional functions, but the second one is more obviously two-dimensional. It'll be x plus iy squared, and then multiply that out, x squared minus y squared plus 2ixy. So you could say that you have a real part with x squared minus y squared, and an imaginary part with 2xy. And so when you do an integral like this, you can split it up into an integral. This 1 to 2 thing isn't quite proper. I'm going to keep writing it, but it's not like quite what you write here. Ooh, and actually, yeah, this gets a little bit weird, I guess. Right, see, for the integrand? I don't know about the integrand. For like the limit there, we could. Um, for the bounds. Yeah, so like the thing that I'm like wrestling with is like this this thing from 1 to 2 is just it's not good enough because of all these different paths. And so instead of saying from 1 to 2, we'll just do a subscript C, and C means some contour, and that's your actual path. I'm showing I don't quite know what to write for the I'm gonna write DS for a little slice on the contour. To actually evaluate it though, you need to do some work on this. That's what I was struggling to kind of interpret, but sorry, this is not the best explanation. But yeah, if you really want to get a geometric interpretation, you can split up into a real integral and an imaginary one. Each of these individually does have a really clean geometric interpretation, which is because now we can just talk about these with three dimensions. For forgetting about imaginary numbers for a minute. Someone say work. Yeah, it's true, Zach. If we have an X, Y, and Z graph, the contour, this always gets tricky to draw. But the interpretation for these, it still has an area under the curve. Imagine in the XY plane, we have some path that we're integrating over. We'll call it C. And then the thing inside the integral, I don't know exactly how to draw x squared minus y squared in 3 dimensions, so I'm just going to draw a generic function that forms a surface. What this integral now means is the area underneath this surface, if you like connect it with the contour. So I kind of imagine it as like this isn't quite the best metaphor, but like the contour is almost like a curtain rod, and you're hanging a curtain from it, and you're getting the surface area of that curtain. So it's still it's still an area, but it's an area that exists in 3 dimensions, and the base of it follows along that contour. And then it gets weird again because one of these is a real number, the other one is an imaginary area. So it's still like it's a little bit hard to actually visualize still because of that, but the geometry still exists. Walrus, hello. I hope you're doing well. Aw, shucks. Okay. And so all of that to say, that's just like we haven't even gotten to residue calculus yet. This is just like what you need to understand before you can understand what residue calculus is. What residue calculus is about, or I guess like, okay, but before we go into that, the important thing to take away from what we just talked about is that when you integrate in the complex plane, you need to say what path you're integrating over. That's the takeaway. Residue calculus now deals with functions that have singularities. And so a singularity, you might not have heard that word, but you have seen them before. If you have the function diagram on the bottom is beautiful. Thank you. Who is Hilbert? How did he get his way into the title? That's crazy. Hilbert is a mathematician who did stuff that I don't know how it works. Okay, so it like the function 1 over x has a singularity at 0. Just thinking about real numbers again. The graph of it looks like that. You're not allowed to plug in 0 into that because you'd be dividing by 0. And so singularities happen when you have division by 0, basically. Yeah. So if I instead have the function, the complex function 1 over z, we're back to being 4-dimensional. This is just our input space here. We have a singularity right at z equals 0. And so residue calculus comes into the picture here because, as it turns out, if you want to integrate with a contour that encloses this singularity, let's just say like the unit circle, that isn't easy to do. If you want to do some other contour that doesn't include 0, like something like that, that is easy. It's actually going to be 0. That comes from something called Cauchy's theorem. And if you've heard of Green's theorem, that's the real version of this. Or at least, sorry, that's not exactly true. It comes from Green's theorem, which is a statement about real variables. But so yeah, if you don't enclose the singularity, you're fine. If you do enclose a singularity, you need to do a lot more work, and that's where residues come in. Residues help you figure out the value of the integral around this contour that is otherwise dangerous. And so I think that's my answer for what is residue calculus. We could get into how you actually do that, but that's a problem that residue calculus deals with. And so yeah, you could also residue calculus also deals with a situation of what if 0 is on the contour, like that sort of thing, like a half circle. So I hope I didn't overload you, but yeah. I'm still curious about my little new number, which is the result from 1 over x to the x equals x. Think while that function goes to infinity, you get e. Oh, 1 minus 1 over x. Or 1 plus 1 over x, yeah. It didn't feel... Okay, good. It's always hard to have a sense for that over Twitch, because if I'm tutoring someone in person, I can like see their face and see how they're reacting, but over Twitch I don't have that, so it can be hard to figure out like how far to take explanations or not. But yeah, there's a really cool relation. So like in complex variables, the you might have seen like the integral of 1 over x dx is equal to the natural log of x in real numbers. And it turns out this is a really important thing that comes up a lot in complex variables. And this is such a strange seeming integral. Like if you integrate any other power of x, you get another power of x. But randomly for 1 over x, you get ln x. And it turns out that even though it's weird, it unlocks so many awesome things. I think while the function goes to infinity, you get e. Another interesting point that might be the point is where it crosses y equals x. Maybe. I don't know offhand if that point would be easy to find. Probably not. One of the integrals I did during a 100 integral marathon was an integral where the contour was the shape of Texas, not surrounding a pole. Oh, nice. Oh yeah, and there's the joke with like what's the integral around Western Europe, and it's zero because you're not surrounding a pole because Poland is an Eastern or Central or Eastern. Is Poland Central or Eastern? I don't know. One of those. It's not Western though. Okay. Um, I forgot where I was now. So I'm right there with you, Lucas. So I guess we've answered 2B, I think. C, I have no. Are we scaling and shifting the Hilbert transform? I tried putting in a Lambert W function, but it didn't work. It was too complex. Oh. Oh yeah, I'm not quite sure I know how to set this one up. Does solving integrals get harder past year 1 of calc? I've been really curious. um, yeah, it does. Unfortunately. uh, it was it was a little bit like extra in the work they made us do, but you could say that uh from here all the way down to here was solving a single integral. And that's 7 pages of work. Oh, that's true. But if you go even higher than this, you just use numerical methods and a computer gets an estimate for you. uh, I did part A off stream. I think I did it right because Wikipedia page matched. We just talked about part B. And then part C. What was the Fourier symbol? That's where's my physics homework. How do the processes change? You basically start with something that's a lot more difficult to work with, and you have to do a lot of stuff to the integral to make it into your normal like calc, like first year calc integral. So instead of like after your first year of calc, the next hardest type of integral you'll learn is with multiple variables. It's like an integral in three dimensions. And you need to learn how to reduce that complicated three-dimensional integral into basically a regular two-dimensional integral. So it's stuff like that. You reduce it down to an integral that you already know, and that's most of the work. I've been really curious about this. How does the plus C integral influence the following integrals? Because it'll be C times X, but what is C? C heavily influences the graph of the function when it gets put with an X value? No. So you do sometimes end up with the constant times some other function like x. But usually that's for a more complicated situation that I don't think you're doing. If all you're doing is an integral of a function like x squared plus 2x, you will never have, like, the constant will never be multiplied by, it's always just a number. It's never multiplied by anything else. The times where it might get multiplied by something is when you're in a different context, like a differential equation, where integrating is just one step of the overall problem. But I'm not really sure what you mean with that, Lucas. Like, where are you getting the c times x from? Oh, if you integrate it again. It's like you just kind of keep integrating the same thing. So yeah, that's a situation where you could get c times x. Or, yeah, where you do get c times x. And now you need another constant d. I'm really good at integrating and solve any integral. I connect my signal to a block with the 1 over s symbol. There you go. It's perfect. But yeah, it's kind of the way that that's just the way that it works, Lucas. I don't know what to say about it. Like, it's supposed to have a bigger influence. Like that, it's just correct that it has that. Part C, aren't you supposed to do e to the IKU minus IHE IKU over 2 equals e to the IKU. Missing, yeah. I think so. I think that's what I did here, I guess. It's just kind of weird, though. Like, I don't know what I'm doing here. And how does P act on a generic periodic function? What does a double integral even mean? Because I think a single integral, yeah, they are different. All right, sounds good, Kirk. See you around. Thank you for hanging out, and thank you for the question earlier. Hope you have a good day. So a double integral like we just did here, it doesn't really mean all that much. Like two indefinite integrals, it doesn't mean anything all that special. Like you're getting the area under a curve twice, I guess, but like it doesn't mean anything all that special. It usually when people say double integrals, they're talking about multivariable stuff. So they're talking about like the integral from 0 to 2 and from -1 to 1 of x times y dx dy. And this is an example of a multivariable integral. Or like this is what I would normally think of as a double integral because it involves two different variables being integrated. And this has an interpretation in 3 dimensions. Fk is a function. Fk is a constant, I guess. Yeah, you could get the volume of a sphere. I guess you would want no, you could get it with a double integral. Yeah, you could do that. Yeah, I guess we're representing f as a Fourier series, and so fk are the constants for that Fourier series. So the issue with this question is I don't know how h acts on a generic periodic function, much less how p acts on a generic periodic function. Is there a word you'd use to describe this type of operator? Never mind. Um, h is linear, and you want to just put in the sum. Really? Huh. H. Let me delete this. This is h's definition here. That's linear? Okay. Linear operators are the best operators. I certainly prefer them to non-linear operators. Oh wait, is Rilbert a combination of Riemann Hilbert? I've been trying to figure out what Rilbert would be his entire time. Maybe it's Riemann Hilbert. I'm still waiting until the homework assignment talks about the Dilbert transform. I don't know if we're gonna get that one though. Spine on each term, you need to justify because analysis might yell you. Yeah, for switching the sum and the integral. We have analysis in the chat right here. Its name is e to the 2i pi. Explain how p acts on a generic periodic function. Oh, okay, so the point is that there's an e to the IKU inside of there. Explain how p acts. Okay, so pk fire. No, I like playing Lucas in Brawl. in Melee, the left hand side looks like a Pokemon. Oh, Pikachu. Yeah. Um. Oh wait, but if P is linear, okay. So wait, I shouldn't do this. It's like P. Yeah, I guess it is maybe a little bit closer to Pichu. Um. So we're gonna say that because of P's linearity, we can just slide P right in front here. I think is where color code is going with this. Like that, I guess. Oh no, I have to justify if you throw enough measure theory at it. Do we need? Uh. So at least, so when I was doing this work before, I just canceled out the E to the IKU. Oh. Oh, fair. Okay. Good catch. Now, didn't we just make this harder? I feel like we didn't make any progress here. Because couldn't we do this again? And like we'll just get a power? Like we end up just that squared and then cubed if we kept on doing it? I don't know why the zero average bit is important. Oh, linear probably is the word of the day here. I don't know how it acts on its image either. I think I'm definitely going to go to office hours to ask the professor about this question because this is a lot of this is just out of left field. Hmm. Yeah, I don't know how to what to think about these two pieces of the question here. Well, including this as a piece. Oops. But we could just give this homework a rest for a bit. So we have made pretty good progress on it. I don't know. It's like the sign function, like SIGN. It's -1 if k is -1 if k is positive. Yeah, k is an integer. So I'm pretty sure it is. I think previously it was just a real number. But yeah, the sign of k comes up from the Hilbert transform. So somewhere on the Wikipedia page that I saw it. Uh, I don't remember if it was this exact thing, but it was like that might be around where I got it. Jake, oh, are people ready? Uh, I can go whenever. I was just planning to end the stream when people got on to play repo. Yeah, maybe we'll just like finish up this one thing and then I'll call it. Break the positive and negative part, because on each part, sin of k will just be a constant. Right. Okay. Sounds good, Jake. Hey, Richard. I see you. Sorry if there's a delay there. That emote is hilarious. What the hell? I only just noticed it now. Oh, no worries. Collar cone. Go take care of that. See ya. If you start it up soon enough, I'll try and raid you. but no rush. Richard, you're from India preparing for IIT? Oh, good luck. That's not easy. Why only five people watch this? I don't know. It's just the way it goes. See, I think with this Hilbert thing, I'm gonna maybe not necessarily even sleep on it, but like rest on it for a bit. Okay, so let's we could get started on something else just for a little bit, because I am planning to go play games with my friends pretty soon, as you just saw. But we can try and get a start on a different homework assignment. This one is for the biology class. I've heard of it, Bridget. I know it's very difficult to get into. I appreciate you being here for history. Every person viewing helps. Geode synthetic division? Yeah. I mean, I never remember how it works, but I can do it. Do you want to give me an example problem? Yeah, so like this is an example of synthetic division right here. The original problem is this: x cubed plus 4x squared minus 8 divided by x plus 4. So I guess we can just use this one as our example. 2x minus 3. Oh, yeah, okay. That makes it a little bit harder. Four x squared minus 8 over 2x minus 3. Okay, this is probably going to not be very clean, but we can do it and see how it turns out. So for synthetic division, we can't have this 2 here. It causes us issues. Yeah, exactly. So you already see what we have to do, which is factor a 2 out from the denominator. So it's going to be like 1/2 times x cubed plus 4x squared minus 8 over x minus 3 over 2. So then, as you say, 3 over 2 goes in this first box. And now what goes here are the coefficients of the numerator. So we have a 1 for that one, a 4 for that 4. And then we need to remember there's like a plus 0x inside there. It's really important. So remember there's a 0 here and then a minus 8. Equal to 0 and solve? Maybe. 2x minus 3. Oh, yes, right. You could do that, but you remember at the end to multiply in the 1/2 though. That's the only thing that I would caution you about, because it will change your answer if you don't have this. But for now, we can just think about this problem here, which comes from the 2x minus 3 equals 0, and then just bring this in again at the very end. You divide the whole thing by 2. That's basically what we did. I guess, yeah, you could also divide everything by 2. Uh, so we would have like 1/2 x cubed plus 2x squared minus 4 over x minus 3 over 2. As far, this should be valid too, if you prefer that. It's going to be complicated with the fractions, but yeah. I don't see anything wrong there. Yeah, so that's I can see why you asked for that denominator, because that makes this a lot harder to use synthetic division with. But yeah, so either way, like, I guess we can do the thing that you said, and we can use this 1/2 to 0 minus 4. And now from here, it's just a matter of kind of running the algorithm. So the 1/2 just comes straight down. And then right here, you do 1/2 times 3 over 2. So 3 over 4. And I think you add your way down. Yeah, you add. Ronaldo, thank you for the follow. So 2 plus 3/4 is 11/4. If x is more than 1, yes. And if it's less than 1, then you multiply. And so I assume you don't need to see like this part, but just to complete the problem, I'll see it through. Yeah, exactly. So, and then once you've taken care of that, then you just solve it like normal. That's easy? Okay, cool. That's good, because this one is getting kind of annoyingly complicated, so I'll leave it there. Glad I could help you, though. You have a test on Wednesday? Good luck. Hope you do well. That's a good question. That's a difficult thing to deal with for synthetic division. Okay, I feel like I don't have enough time to get started on this before I want to head out. Maybe we'll just call it. Yeah, I think that's what we'll do. So that way I can like go and use the bathroom and stuff before I go to play games. So yeah, I guess thanks everyone for being here. I'm gonna cut the YouTube stream off here. People on YouTube, thanks for being here. Yeah. At best I'll stream again next Tuesday for math, but I'm not sure exactly. So see ya, YouTube.